In this video, we're going to learn how to transform equations between polar and rectangular forms. Now, in the previous lessons, we learned how to convert points between the two, but now we can take full equations because you can't have an equation that's in polar form, like r is equal to 6 cosine of theta, and put them into rectangular coordinates so you can see what their graph would look like. So for example, r equals 6 cosine of theta could be graphed on this polar grid, but if we convert it to rectangular coordinates, you might be able to see what this graph can be a little easier. So if I wanted to convert to rectangular, I'm going to use all the formulas we've been over so far. And I'm going to see here, I don't see anything just for r, and I don't see anything just for cosine. But if I were to multiply each side of this equation by r, I would get r cosine, which is x, and r squared, which is x squared plus y squared. So I will multiply each side by r, giving me r squared is equal to 6r cosine of theta. And now I can just replace r squared with x squared plus y squared equal to 6 times r cosine theta, which is just x. Now, if you can't tell what this equation is graphically, it's actually the equation of a circle, which is one of the conic sections. The way you can see this is actually move everything to one side of the equation. So x squared minus 6x plus y squared equals 0. And then if we complete the square on the left side, which means taking half of negative 6, which is negative 3, and squaring it, adding that to each side of my equation, I can get a perfect square trinomial, which would be x minus 3 squared plus y squared is equal to 9. And this is just the equation of a circle with a center of 3, 0, and a radius of the square root of 9, 3. So if I were to put the center at 3, 0, so 1, 2, 3, and do a radius of 3, so 3 in each direction, so 1, 2, 3, 1, 2, 3, all the way off to the edge. We can draw a circle, which is what that graph would represent. Now, if you wanted to see if this works, you see this point right here. It looks like it's on that angle at pi over 4. So that means if I were to plug in pi over 4 and for theta, I should probably get that radius. It looks like something near 1, 2, 3, 4, a little bit past it. A little bit past 4. And I can kind of check my solution. So r is equal to 6 times cosine of pi over 4. It would be r is equal to 6 times square root 2 over 2, which is 3 square roots of 2, which if I were to plug that in, 3 square roots of 2, I get something a little bit bigger than the radius of 4. So it does make sense with that graph. I'm not going to check all of them like that, but that is one way you can check to see that the points are lining up in the right spot. Now let's look at r is equal to 2 over 1 minus cosine of theta. So already I have a very similar situation as I had up here. But what I'm going to do is multiply each side by 1 minus cosine of theta, give me r times 1 minus cosine of theta is equal to 2. Then I can distribute r and get r minus r cosine of theta is equal to 2. Now, I have r cosine of theta, but I do not have r squared. But what I can do is, on rare occasions, it might help you to make r equal to x squared plus y squared to help you convert to your equation. That gives me the square root of x squared plus y squared minus x is equal to 2. Now, you usually don't want to keep that square root in there if you can. So I'm going to add x to the right side to get x plus 2 on the right, and then I'll just square each side of this equation to get rid of the square root, giving me x squared plus y squared is equal to x squared plus 4x plus 4. And then I see here I can subtract x squared from each side, give me y squared is equal to 4x plus 4. This is a much better looking equation than up here. But now what type of graph is this? Well, this is actually a parabola. I mean, you just have one of the x variables squared. That represents a parabola. And the best way to find all the points for it is if I just plug in 0 for x, then y squared equals 4. So when x is 0, y is either positive 2 or negative 2. And when y is 0, x is equal to negative 1. And I can create my parabola down here with its vertex at the bottom. And another way you can also see that parabola as well is to solve for x, giving me x is equal to, or 4x is equal to y squared minus 4, divide by 4, and you get 1/4 y squared minus 4, or minus 1, which tells you that the vertex is at negative 1 comma 0. And then you can find the focus points to find the other spots, or just plug in some values to find the other spots as well. Now let's look over here where we're given the rectangular equations, but we're going to find the polar equations. Now, we can more easily graph when it's in rectangular form. Because here, if I just solve for y, I get 9 over 4x. So an easy way to graph this would be, I know this is a rational function, so it has these vertical and horizontal asymptotes. And I could just plug in a value for x, like when x is equal to 1, y is equal to 9/4. So 1, 9/4 would be 2.25, so point up here. And if I plug in, so for example, 2, I get 9/8, which is at 2 is a little bit above 1. Plug in negative 1, I get negative 2.25. Negative 2 gives me negative 9/8. And I can kind of just sketch the rational function from there. But we're going to try to represent this equation in polar form so you can see what the similarities might be. So again, we have x and y, which I know are just r cosine theta and r sine theta. So I can actually just outright replace those. So I can write this as 4 times r cosine theta, and y as r sine theta is equal to 9. From here, I can just multiply these together, give me 4r squared is equal to sine of theta times cosine of theta, which is equal to 9. And this is a perfectly fine way to write your equation once you have it all written in. But I do have sine theta cosine theta, which reminds me of the sine double angle formula. If I were to just write 2r squared times 2 sine theta cosine theta, I can actually reduce the trig functions in this just to be sine of 2 theta, which might be a little nicer to have written instead. But these are both fine answers. I'll put the other one in the bubble because this seems like a little extra work to get there. But this equation would represent a rational function. Now, x squared plus y minus 3 squared equals 4. That is a circle, but we're going to show how to go in the other direction to a circle equation, which might not always look exactly like this, but let's see. We have our center here at 0, 3, and a radius of 2. So 0, 3, radius of 2. So we're going to get a graph that looks like this, but we're going to get the polar form of it. So in order to do this, first you want to expand everything, especially if this is y minus 3 squared, since most of these x and y's are just by themselves. It'll help you out the most. So we'll rewrite this as x squared plus y squared minus 6y plus 9 when I expand y minus 3 squared. And then what I can do is I can subtract 9 to the right and be left with x squared plus y squared minus 6y equals negative 5. And I know what x squared plus y squared is. That's r squared. And I know what y is. That's r sine theta. So I can put 6r sine theta equals negative 5. And just to make that a positive value, I can write this as r squared is equal to 6r sine theta minus 5. And that represents that circle. Usually the most ideal way you can write polar equations is just to have it r equals. But that would cause this to be like a plus or minus situation, which I definitely don't want to have here. And the same thing up here. If I got the theta by itself, I would have a plus or minus a square root. So I'd rather just keep the r squared in that instance. And if I wanted to check to see if this was right, I see here along the pi over 2, there are 2 points. So I could probably just plug in pi over 2 for sine and solve for r, and I'd probably get the radius to be 1 and 5. In fact, I'm going to do that right now just so you can see how that works. So if I were to plug in pi over 2, which is this upward angle, I would get r squared is equal to 6r times sine of pi over 2, which is 1. So I just get r squared is equal to 6r minus 5. I can move everything to one side of the equation, giving me r squared minus 6r plus 5, which if I factor that, I get r minus 1 and r minus 5. That's a radius of 1 and a radius of 5. So that does work. And that is how you transform equations between polar and rectangular forms.